Welcome to Brain Vision.
For part A, to calculate the energy of a photon that is released from an atom during the transition between the n equals 5 to the n equals 3 state, we're going to use the equation that says that the energy of that photon, E, is equal to negative 13.6 electron volts, where negative 13.6 electron volts comes from the ground state energy of the hydrogen atom. And we're dealing with a hydrogen atom here, and then this is multiplied by 1 over the initial state squared, which is 5 squared, minus 1 over the final state squared, which is 3. So this is 1 over 3 squared. So if we carry out this operation, we find that the energy of this photon in electron volts is equal to 0.968 electron volts. For part B, it wants us to use this information to calculate the wavelength. So to calculate the wavelength, we're going to use the fact that energy is related to wavelength through the equation E is equal to Planck's constant h times the speed of light c divided by lambda, the wavelength. So we can rearrange this equation to solve for lambda. We have lambda is equal to h times c over the energy. Since our energy is in units of electron volts, we want to use a value of Planck's constant that has units of electron volt seconds instead of joule seconds. So in electron volt seconds, Planck's constant is 4.1357 times 10 to the minus 15 electron volt seconds. The speed of light is still in meters per second, so it's 3 times 10 to the 8 meters per second. And carrying out this calculation, we find that the wavelength is equal to 1.28 times 10 to the minus 6 meters, or 1.28 micrometers. You can write it either way. I'm going to write it as micrometers, but you could also write it as 10 to the minus 6 meters. And then lastly, for part C, we're asked to find the frequency. And this can easily be done from the wavelength. So the frequency, by definition, is equal to the speed at which the object is moving. In this case, it's light, so it's c, divided by the wavelength of that object. Plugging these values in, and make sure you convert wavelength back to meters, so it's 1.28 times 10 to the minus 6 meters. And the speed of light is in meters per second, 3 times 10 to the 8 meters per second. And this comes out to equal 2.23 times 10 to the 14 hertz. Where a hertz is the same as a unit of 1 over seconds, but we're going to use units of hertz since that is the common SI unit for frequency. And we can box it in as our solution for part C.